Thank you very much for having me, the organizers of this laudable conference. And I want to thank you for your kind words of introduction. I will go straight away to give my presentation. Okay. Yes. I think I have to reduce it. The title of my presentation is Climate Change-Driven Disasters, Need for Pragmatic Mitigating Policies. And I would like to minimize this before I can. Just a minute. Oh, okay. Yes. So I have some few outlines here. I'll talk about introduction, and it's on the climate system, the Earth's climate, climate variability. Climate is changing, the uncertainties. Then I look at some scientific background, trends in climate change parameters, climate change impacts, pragmatic mitigating policies. The warming of the climate system is unequivocal, as it is now evident from observations of increases in global average air and ocean temperatures, widespread melting of snow and ice, and rising global average sea level. The last 12 years ranked among the 12 warmest years in the instrumental record of global surface temperatures. According to IPCC, the fourth assessment report of 207, the linear warming from 1956 to 2005 was 0.10 to 0.16 degrees centigrade per decade, which is nearly twice that of the 100 years from 1906 to 2005. The Earth's climate is such that the extraterrestrial factors are the solar output, the Earth-Sun geometry, the dust, the volcanic emissions, the mountain building, the continental drift, atmospheric oxygen, atmospheric reflectivity. They all add up to what we know as the Earth climate. The ocean, the atmosphere, and the land factors are all part of the aspects we have to look at. The natural mode of climate variability includes El Nino, the North Atlantic Oscillation, the MJO, other Pacific decadal oscillations, that is the others, and then the Atlantic multi-decadal oscillations, and the Indian Ocean dipole and Pacific North American patterns. These oscillations represent coupled interactions between the atmosphere and ocean. The influence of each mode varies depending on the season of the year. El Nino is projected to continue as most prominent mode of natural variability. As climate changes globally, there may be changes in patterns of natural variability in terms of their strength, frequency, and other aspects. The climate is changing. Sea levels are rising. The ocean is acidifying. Climate change is reflected in water cycle changes and in extreme weather. If you look at the map I have on the temperature rise, you see how the whole place is becoming, dotted with a lot of reds, which means the Earth's surface temperatures has risen to approximately 1.3 degrees Fahrenheit since 1850. There are a lot of uncertainties. The scientific uncertainty is the lack of exact climate knowledge, regardless of why this knowledge deficiency exists. And it is expressed by several renowned scientists leaders, and political people, mostly from developed nations. IPCC's first assessment concluded no evidence in the real-world data to warrant alarm. 2 years later, another report was commissioned for the Rio Earth Summit, and the conclusion was again the same. The cartoon I have here shows that in 1990, our speaker told us that, so this is climate change, and this could be a problem. 1995, it was the same, climate change, definitely a problem. Then 2005, yeah, we should really be getting some sort of understanding. 2007, we said, sorry to sound like a broken record. Then we came to 2019, and the speaker refused to work, and he had to tap on it. Now, more than a decade of intense study of climate change by scientists has been carried out. There is still uncertainty, which limits the ability to predict the magnitude, timely, and regional distribution of impacts. Human beings are really at it, and then their activities have increased concentrations of greenhouse gases in the atmosphere. These gases get trapped and cause the earth to warm. Now, the carbon dioxide that is emitted through humans' activity before 1950 was on a level that we could all see as, okay, normal. But right now, current levels is looking like we are getting to the tipping point. And so it's a bit concerning. Scientific backgrounds of global climate change. Many aspects of the Earth's atmosphere are undergoing significant alterations as the direct consequences of human activities. Recent and abrupt increase in global temperature is leading to a warming that over 12,000 abstracts agree to as real. Observed changes in the temperature is abrupt. 16 to 17 warmest years recorded globally happened in 2000. 11 of the 12 years between 1993 and 2006 had the highest recorded surface temperatures since 1850. And between 2005 and 2010 were the hottest year on record. So leading scientists from around the world have reported major advances in our understanding of climate change. Indicators of climate change, measurable parameters that influence the properties of the Earth system. They are the atmospheric, which involves the air temperature, the air pressure, the air temperature, precipitation, and solar radiation. Non-atmospheric parameters are the sea surface temperatures and ice cover. So the clear indicators of climate change are air temperatures, Arctic sea ice, which is decreasing, glaciers melting, sea levels rising, ocean heat content increasing, sea surface temperatures increasing, and the snow is decreasing. So let's look at some of the trends in the climate change parameters. The temperature. Thermometer observations have shown temperatures have been rising at the Earth's surface. Warming can be explained as the increase in greenhouse gases, principally carbon dioxide. More than 80% of scientists agree that human influence has doubled the risks of the occurrence. For sea surface temperatures, during the past 4 decades, sea surface temperatures have exceeded the 20th century average every year and are now higher than at any other time since record began. Much of the heat trapped by the increasing atmospheric greenhouse gases levels is absorbed by the ocean, causing the sea surface temperatures to rise. For ice sheets, these are now threats to global sea levels. The ice front, where the glaciers calves into the sea, receded more than 40 kilometers between 1850 and 2006. Between 1850 and 1964, it retreated at a rate of 0.3 kilometers per year. Currently, the rate of recede is 3 kilometers per year. All the ice sheets in Greenland, Antarctica, Arctic, and other parts have become very sensitive to change. Satellites are providing a remarkable series of tools to provide scientists detailed views of how the ice sheets are thickening or thinning. The significant issue to ponder right now is how the ice streams are being transported into the sea. Evidence of sea level rise. Estimates for the 20th century sea level rise show that global average sea level rose at a rate of 1.7 millimeters per year. Global average sea level rise from 1990 to 2100 for the 6 special report scenarios is to be between 0.25 to 0.45 meters by the end of the 21st century. Sea level rise records are from tidal records, from coastal measurements, and also from satellite information. So the sea level changes reflect changes in the global ocean volume. Higher sea level means the ocean volume has increased. Principally, we have 2 ways: melting ice, which result in increased volume of water, and the warmer oceans, which take up more space. Population growth and climate change are very important aspects of a parameter to, it's not a climate change parameter, but it's on its own. Human population has increased from 1 to 10 million 12,000 years ago. Right now, we have over 7 billion in 2020, and we are still counting. Man's activities have increased enormous impact from local, regional, and to global level. Using the atmosphere, ocean, and land as dumping grounds exacerbate the impact. Cities are now transformed to mega cities, spewing vast mixtures of chemical into the atmosphere. The total number of people currently living is estimated to have reached 7.8 billion. By 2050, the number will be 9 billion. Therefore, over 50% of the total global population dwell in cities and produce 75% of carbon dioxide, which is in terms of transportation, electricity, industrial activities, and agriculture. Cities are equal to climate change. Cities are climate change enablers. Most cities in the world are situated around large water bodies contiguous to the ocean. South America and the Caribbean are the most urbanized developing regions in the world. In 2010, 83% of the population reside in cities. Less than 20% of the population of Latin America is concentrated in largest cities. Megacities are becoming the focal point of climate-induced disasters, vulnerable to climate change impacts. According to UN DESA 2015, emerging African cities will face increased exposure as a result. The exposure and the embedded conditions of socioeconomic built environment, spatial and institutional vulnerability produce disaster risks when hazards occur. These are some of the climate impacts we'll see around. Higher temperatures, changing landscapes, stronger and increased hurricanes, super typhoons everywhere, economic losses on quantum levels that it cannot be understood, increased risks of drought, fire, and floods, and more heat-related illnesses will be what we'll be seeing from here on. Ecological impacts are also one of the issues. 11 things are intimately connected to the physical surroundings. Ecosystems are affected by changes in terms of temperature, rainfall, salinity, pH, activities of distribution of other species, and many other factors. As a result of climate change, species and ecosystems are experiencing changes in ranges, timing of biological activities, growth rate, relative abundance of species, cycling of water and nutrients, the risk of disturbance from fire, insects, and invasive species. This is to show you the before and after effect of Hurricane Sandy. Hurricane Sandy impacted the New York and New Jersey coastline in October 29, 2012. The death toll was 286 people, and this was those who were directly killed and those who were indirectly, affected. Areas that were affected was beyond the US coast. It included the Caribbean, Haiti, and Cuba. The Bahamas Hurricane 2019. The estimated damage was 5.1 billion. And this thing happened just in 2019. It was a Category 5 hurricane, and it affected the Bahamas, Florida, and North Carolina. And you can see from the picture, the before, how beautiful, how lustrous the city was, but totally devastated. Most homes lost, a lot of people dead. There comes the super typhoon Haiyan. The Southeast Asia in October 2013 recorded 14 typhoons. And the 15th one was a super typhoon, which was Haiyan. Haiyan brings along howling winds, intense rainfall, tsunami-like storms, and a surge in November 2013. And the number of people who lost their homes were 6 million. Those who lost their jobs were 6 million. Those who lost their homes were 4 million. And the devastation was on a grand scale that is frightening to think that we could have such super typhoons happening due to climate change. In Lagos, we also experienced some storm surges. It's on a small scale compared to, typhoons and hurricanes, but it also carries the topsoil totally away. For example, the tide gauge housing that we had in 2009, by 2011, it was totally gone. We put in another one, it was also totally gone. The increase in rates of erosion due to the storm surge, it's one of the highest in Africa. That is rates of between 25 and 30 meters per year. There is need for us to really assess what we have to contend with. So we have to take the assessment. And this particular assessment, I was looking for a very simple one to be able to explain that the hazards we have are the floods, the heat wave, the storms, and high winds. The vulnerability aspect is our infrastructure, the communities we stay in, and the type of houses we build. Our adaptive capacity will be the information and resources we receive, the stakeholders' interactions with the communities, institutions, and the government support. This was taken from the Urban Climate Change Vulnerability and Risk Assessment Framework, adopted from Rosenwood. So we need organizations to help individuals identify their climate risks or test their existing risks management strategies. If it is not well placed, then we need to go back to the drawing table. So disaster and risks in cities. Yeah, the effects of climate-related disasters are exacerbated in cities due to the trimmings of modern-day cities. Attention must be directed at coastal cities where more frequent and severe weather-related disasters are anticipated. Attention must also be focused on disaster risk reduction and enhancing resilience through effective risk management, adaptation, and urban planning system. For example, the picture I have here, I got from the internet, and there was a lot of rain in Pakistan, and Pakistan was looking up to the US. So the question that was under the picture was, why was Pakistan left out of Biden's climate summit? Meaning that the whole world is looking up to key leaders to help in unraveling what is about to confront us. Pragmatic mitigating policies. Climate change mitigations are actions to limit the magnitude or the rate of long-term climate change. This is generally involves reduction in human emissions of greenhouse gases. Pragmatic mitigation policy, the journey. The United Nations Framework Convention on Climate Change entered into force in March 1994. And the aim was to reduce greenhouse gas concentrations in the atmosphere to a stabilization level to prevent human interference with climate system. In the same year, we had the former chairman of IPCC on objectives to reduce climate uncertainties. And his words, I read, "We cannot be certain that this can be achieved easily, and we do know it will take time. Since a fundamentally chaotic climate system is predictable only to a certain degree, our research achievements will always remain uncertain. Exploring the significance and characteristics of this uncertainty is a fundamental challenge to the scientific community." Now, this statement about uncertainty really tells a whole lot of things about. And the UNFCCC had to look for a way out. So came Kyoto Protocol, which was adopted in December 1997. It's an international agreement aimed to reduce carbon dioxide emissions and the presence of greenhouse gas in the atmosphere, especially for industrialized countries. So that you see that the Kyoto Protocol was an extension of the UNFCCC. Well, this was massaged for a long time, and I think that the world leaders found out that it was not really working perfectly. So they came up with the Paris Climate Agreement, and this was signed in April 2015. There was 195 signatories. The goal is to limit global warming to well below 2 degrees, preferably to 1.5 degrees Celsius compared to pre-industrial levels. The Paris Climate Agreement, this was signed by both developed and developing nations. They all felt committed to the Paris Agreement. The parties are invited to submit periodic long-term low greenhouse gas emission development strategies. And a single transparency framework is established. All the parties, in exception of the least developed countries and then small islands developing countries, were left out because they knew of the importance of the financial implications. So this Paris Climate Agreement was to focus mainly on developed countries reducing their greenhouse gas emissions. So work was done. Now we find out that there are countries that have the lowest greenhouse gas emissions in the world. Tuvalu, Niue, they are all island states, and Tonga. You see that in the case of Tuvalu, I think it's an utopian world. It has a 0 emission. Now, comes the highest green carbon emission countries, which is Japan, which is the least of the highest. Then come Russia with 1.693 metric carbon per year. Then India, the United States, then China, the biggest of them all in terms of carbon emissions. Globally, there should be transformational shift towards low emission development pathways compatible with the objectives of the United Nations Framework Convention on Climate Change, Kyoto Protocol, and the Paris Agreement. Mitigating climate change is about reducing greenhouse gas emission. Low greenhouse gas emission is equal to low carbon emission. Reducing carbon footprints. The carbon footprint, that is the amount of carbon dioxide released into the air, consumption through the consumption of fossil fuel coal, is what one has to calculate so that we can all arrive at the same junction. For the least developing countries and the small islands, even though Paris Agreement let them out in terms of calculating their emissions and submitting those emissions, they still had what they gave them in terms of activities that will also assist them in getting less vulnerable and look at the impacts. And these include livelihood diversification, literacy, women's rights, community health, food security, water supply. And when you come to theme 4, relocation due to sea level rise, coastal defense from sea level rise, and then extra storage to capture glacial melt. So these are some of the themes that the least developed countries also have to go through and adhere to. Some of the mitigating policies are anti-desertification efforts, which we have the Northwest China exhibit. And from before and after, we see the transformation of desert environment to a vegetative environment. And this is laudable, and even developing countries can also follow and take part of this project and make it globally acceptable. Some of the examples of mitigating climate change are switching to low carbon energy sources, such as renewable and nuclear energy, expanding forests and other sinks to remove greater amounts of carbon dioxide from the atmosphere, and geoengineering. Some of the everyday choices that we need to do, for example, which includes you have to do it, not necessarily the individual nations, but individuals in a country. You have to calculate your carbon footprints in terms of electricity, the kilowatts you use. Broad daylight does not need light because the sunlight is enough. So that when you have a carbon footprint of 2,500 kilograms per year, that is excellent. But when you go beyond it, well, it is good. When you are really getting out of that, that is poor. So when you have all these in mind, you'll be able to assist in understanding your carbon footprint and reduce it. In the homes, we have to be responsible for 20% of the carbon emission release are from the homes. So when we reduce our carbon emissions from our homes, we are helping the whole global effort. There are some practical mitigation that I always share with students and when they come around to understand what climate change is all about. Decision makers, urban planners, they should integrate efforts to mitigate the causes of climate change and adapt to changing climatic conditions. Cities need systematic greenhouse gas emission inventories. That is, individual cities must have their own inventory, irrespective of the country. and emission reduction pathways in order to prepare for mitigation actions. The claptrap of climate uncertainties by some heads of state, political leaders, scientists is very confusing and discouraging to least developed countries and small island states. In conclusion, I want to say that climate change-driven disasters are a global issue and the biggest challenge of the 21st century that has far-reaching ramifications on humanity and the environment. Disaster risk reduction and climate change adaptation are the cornerstone for reducing vulnerability, and this should be embraced for better evacuation planning and the development of coastal defense mechanism. A broad educational program on the basic science and societal impacts of climate change and sea level rise is needed to better inform businesses, regulators, governments, international bodies, and the public on mitigation measures. From this flight mode, you see that we all need to head towards the same direction for success. An African proverb says that you need two hands to break a calabash. And a Russian proverb says that you cannot take one part of a fowl for cooking and leave the other part to lay eggs. We all have to be going the same direction if we have to succeed at that. Thank you for your kind attention.
Thank you so much. I do believe we have a few questions from the audience, and if anyone else from the audience has any questions arise, feel free to use the Q&A function, and I'll go ahead and start reading them out. One first question is, what are the implications of this sea level rise for coastal cities like Miami and Florida, for example?
Should I answer as you ask?
Yes, please.
Yes, for increases in sea levels, it translates to erosion on the coastline, storminess, and erosion of houses and livelihoods that lie along the coastline. And it makes the coastline very unsafe because you can have a storm at any time. So as I said before, sea levels means the increase in the volume of the sea. And that means that a lot of areas will be eroded, will be taken over by the sea. Roads will be washed off or will be taken over by the sea. So those are some of the implications of sea level rise.
Great, thank you. Another question is about megacities, asking if megacities are hit hard by disasters, should or can we make megacities small or compact? And how can we shrink the megacities that already had exploded by now?
Yeah, megacities. I don't know how we can shrink megacities because they are already in place and increasing because of the attraction to the cities, various people from some communities, from some other landlocked areas, they want to have the feel of the ocean. So they come, but it is very difficult. But I don't know how governments are going to start thinking of how to create sectors in the megacities. But most important is that there should be set back lines put in place. That is beyond which you cannot build any house. It should be around 300 meters away from the shore so that you will not have a severe impact of storm surges or hurricane impacts. So mega cities are there, but we will have to relocate those houses and people who are very close to the shoreline because obviously they are going to be impacted. They are going to be affected by storm surges and other issues.
Great, thank you. Another question we have, with the soil history, we can see that CO2 levels have been higher before in the history of the planet, and that during that time, while there was a decline in animal populations, the plant and tree populations boomed and caused a reduction in atmospheric levels. And this question is, can we use these same methods ourselves in order to reverse these effects before we die out and the planet does it on its own?
I think we are really getting to a very scary part. People refer to it as the tipping point, because the rate at which temperatures are increasing, it's just beyond, understanding. And we do not know what the implications will be for more increases. We don't know, nobody knows, but what you have said is right. In the past, it has affected the animal, population, and we should be sure that this will also affect us. Because I have records of heat waves and temperatures in the UK, for example, climbing as high as 37 degrees centigrade. That is like 117 degrees Fahrenheit at a point in the year 2000. It resulted in several deaths. So if temperatures increase beyond the levels we have now, of course, a lot of people are going to die. Ecosystems are going to be, they are going to thin out, and even some animals will get extinct.
And one other question I see written, how do we make industries and cities sustainable without hurting the economy?
Yeah, just like the Paris Climate Agreement came to a conclusion that individual countries should submit their carbon emission, records. I think the government has to now get to the nitty-gritties of requesting industries to submit what they are emitting out and ensure that they reduce their emissions, because you can't put all that into the equation for a country, because there could be some situations where some companies, they will refuse to actually report on their actual emissions. So industries have to be charged to submit records of what they are doing, what they are emitting. They should be charged, and there should be people to monitor what they are, they're really putting down, so that we see the transparency of what they are doing.
Definitely. I think that Franco had a question. Feel free to ask away.
Thank you. Yeah, thank you, Regina, for this really informative presentation. You covered so much ground that's so important. So thank you for that. I'm just curious, in your work in disaster risk reduction, if you've come across cities that are particularly advanced in reducing risks in advance of disasters, because as we know, I mean, in the United States, very often a disaster occurs, and then the discussion is the risk has already occurred, and it's about recovery and rebuilding. But so much of preparing for disasters is actually preparation, is actually advanced action. And I'm wondering if in your research globally, there are cities that really stick out for you as having laid the framework to reduce the risks of disasters before they occur.
Yes, there are cities. For example, I've been to New York several times, and I see the protective structures, along the coastline, and people not living just too close to the waterline as it happens, as what happens in developing countries. Yet when the Hurricane Sandy came on, it's really impacted most of the areas in the city. The important thing we should note here is that the intensity of the hurricanes are going to confound our assessments and provisions for safety of cities. So we have to start increasing the level of protective structures that we are going to put in place, or whatever is there, we have to re-enhance it, because climate change is going to really challenge what we have put down as going to, ameliorate the problems, the issues.
Thank you.
One additional question for you. Can you discuss more about adaptation and resilience in the context of Nigeria or the greater continent? And are there any examples that you find to be particularly successful, particularly in reference to how communities work together?
It's really sad that, there are some least developed countries that do not even understand what adaptation means. First of all, they are totally removed from the communities that are suffering from issues of climate change. For example, I was at a community very far off for a survey, and there was a storm surge, and I saw 8 strong men holding the 4 corners of the house and moving into mangrove. And that is their form of adaptation, which is very crude, which is very disheartening. But, there are some communities in terrain that you can't do anything about it. For example, the terrain that these people were, trying to help themselves is a muddy terrain. You can't go and a structure to create some stage there. They need to live there. So there are people who are really living in a very awkward situations that having adaptation plans for them, it's a bit difficult because those type of people, you cannot convince them to leave that community entirely because the community is linked to their livelihood. So adaptation doesn't come to play. It does not get to convince them that this thing is real and you need to get out of there.
Now, I have a question about preparing students and educating them about how to be responsible travelers, particularly when they study abroad or volunteer abroad or do any sort of work abroad. And I wonder if you could touch on what you might think a best practice would be for integrating teaching students about sustainability or sustainable tourism practices to mitigate the risk that they might pose through studying abroad or living abroad somewhere short term.
Okay, it's interesting to have students who are studying abroad and seeing developed ways of adaptation and mitigations. But I will want them to also cast their minds back to communities they are coming from. What they have in, for example, the United States is not what they have at home. Therefore, whatever they are learning, they have to be able to reflect on how to integrate those understanding to that of the least developed nations. They will be at the forefront of breaking down the understanding, the concept of mitigation and adaptation in terms of climate change to the communities they are coming from. So a lot rests on their understanding of climate change issues, adaptation, and mitigation, policies, because they will be required to feed these developed communities, what they have come to embrace in the development countries.
Great, thank you. One other question, with weather phenomena being chiefly due to combinations of differing temperature systems, is it more the variability of the climate and this flip-flopping that's occurring, especially in transition seasons, that is causing the greatest threats by having high and low temperature and pressure systems colliding as they rotate around the moving planetary surface? And is there a way to help this?
I don't see how you can help the climate system, the Earth system. The Earth system hates so much emissions of greenhouse gases. The only thing we can do is how to reduce it and see whether it will assist in curbing the rising temperatures. Other than that, I do not know how to really answer best way.
It's a complex question. Are there any additional or remaining questions from the audience that we can take at this time? If not, we can go ahead and close out. Thank you so much, Dr. Folorunsho, for the time and the very important issues that you raised in your speech in such a short amount of time. We really appreciate it.